Okay, so let's take a look at this one. Divide x cubed minus 7x plus 6 by x minus 1, right? X minus 1 into x cubed. I'm going to do plus 0x squared as to fill in, keep the place, minus 7x plus 6. Okay, x minus 1 into the first two terms, so I look at the x and the x cubed. X to x cubed would be x squared. Then I multiply the x squared times x, and I get x cubed minus x squared. Subtract. First term goes away as expected. Then I get 0 minus minus, so plus x squared is x squared. I'm doing two terms as a divisor, so I need another one, minus 7x. And now I go this x to x squared, and that's plus x. I need a plus x to do that. Multiply the x times the x minus 1, x squared minus x, and subtract. X squareds go away. Minus 7x plus x is minus 6x. Okay, then we need another term. Bring it down. Plus 6. And repeat again. X to minus 6x. I need a minus 6. Minus 6x plus 6, because the minuses cancel. Subtract. And notice this time, not only do the first terms cancel, 6 minus it gives me 0. And I'm below my power of the divisor, so this is it. 0 remainder. So what does this mean? So this means that I can write x cubed, let me just label this as the meaning, x cubed minus 7x plus 6 as x minus 1, the divisor, times x squared plus x minus 6, and that plus 0. So I'm not going to write that, but look what I've done. I've actually done some factoring. I was able to express this polynomial as a factor of two other polynomials. So, in particular, I showed that basically this x minus 1 factors out of this. So the 0 remainder means x minus 1 is a factor of x cubed minus 7x plus 6. And that's what I've been going for. And now I have a connection between what the remainder of a polynomial division, how that connects to something that's in factoring. And that's what I note right here. The remainder in a polynomial division is 0 when the divisor is a factor of the dividend. Okay, and that's what we saw. This x minus 1 was a factor of the dividend, and hence I got a remainder of 0. There's more to it though. Note this. This is nice. So let's make that dividend polynomial, the x cubed minus 7x plus 6, to be a function, f of x. And let's see what happens when I put 1 in. Well, 1 cubed, we'll see why we're putting 1 in a minute. 1 cubed minus 7 times 1 plus 6 is 1 minus 7 plus, that's 0. Okay, well, that's nice. So when I put 1 into f, I get 0. Okay, what does that mean? Well, that makes sense because remember we just wrote the polynomial up there as x minus 1 times x squared plus x minus 6. And indeed, x minus 1 is 0 when x is 1. Meaning this evaluation of f of 1 had to be 0 because I was going to get a 0 times something else. Makes sense. So when I divided by x minus 1, I was really dividing by something that would be 0 when x equals 1. So that tells me that 1 would make f equal to 0 if I looked at that dividend as a function f of x. There's another connection. Now I not only found a factor, I found a number which, when plugged into the function version, gives 0. So what if we tried a different thing? What if we divided f of x, x cubed minus 7x plus 6 by x minus 3 instead of x minus 1? All right, well, let's see. We can do that. X cubed, I'll again put in 0x squared minus 7x plus 6. All right, x minus 3 into the x cubed plus 0. So x to x cubed is x squared. Multiply that out. X cubed plus 3x squared. Subtract. That gives me a minus a 0. Whoops, I'm sorry. I made a mistake there. That would be x squared times minus 3 would be minus 3x squared. So 0 minus minus, so plus of 3x squared. I need another term, minus 7x. X to 3x squared. I need a 3x, so plus 3x. And so I get 3x squared minus 9x. Subtract. So I get minus 7x plus 9x is 2x. Bring down the other term, the plus 6. Okay, do it again. I need x to 2x. And that would be 2. So plus 2. And I get 2x minus 6. Now when I subtract these, I don't get 0 because I get 6 minus minus, I get 12. Okay, so I did not get a remainder of 0. All right. But notice, if all I wanted to know was what the remainder was, I didn't have to go through this whole thing. I could have said that let's look at this thing as a function f of x. All right, plug 3 in. So 3 cubed minus 7 times 3 plus 6 is 27 minus 21 plus 6. That's 6 plus 6, that's 12. Oh, look at that. That's not a coincidence. What I found is I can actually find out what the remainder would be if from dividing x minus 3 by putting in 3. So if I want to do a division by x minus some number, I could put that number in to the function and find out what the remainder would be. So specifically, we're going to be looking to find out when the remainder is 0. So I don't have to go through this whole procedure if that's all I want to find, the remainder.